Guess who's back? Back again. And yes, I am back, guys. We are here. You can see these whole new house, whole new things. And yes, there have been multiple things going on. I hope, first of all, you can hear me right. Please just type in the comments if you can hear me. If you can, please just type in the comments because this stream is gonna be huge. First of all, the rocket itself is going to have certain things which we are going to discuss. But apart from that, we will also be having my updates, and then we will also yes. Hi Freddie Williams, hi Nishant, how are you doing? I hope I am audible. All right. So first of all, hi. Welcome, welcome. And yes, there was a huge 1 month, 1 year long gap which was there, but I hope now it is all fine. I'll share my updates a bit later because the streams have already started. So I'll just share what we are going to do today. So first of all, you are going to see a special Rocket Gyan 2.0 from now on. Okay, which means there will be multiple videos coming up every week, which I'm trying to do. There are things which are in working in parallel in the pipeline, which will be released very soon. And yes, everything is going to be very smooth. So first of all, we are all right. Yeah, first of all, let's just talk about this rocket, and if we get time, then I'll talk about myself. Okay, so this is the rocket which is going to go today. We are T minus 57 minutes from the launch. This is the Skyroot's um Vikram 1 rocket, and this rocket is going to be flying today. This is a 4-stage rocket which we will be showing, and I am showing you right now. I'll show you right now the thing which is there for the Rocket Gun 2.0, which I made very recently, and I forgot how to switch tabs. Very good. Yeah, there you go. All right. Yes. So this is the explorer which I made. I hope it is visible to you all. And here we will be seeing all the things that are related to rockets. I have currently added. Is it visible? Yes. I've currently added this Vikram 1 rocket, which will and the PSLV rocket and the Falcon. And this is made from scratch. This is literally made for you guys so that I can show you, explain you what all are the components of the rocket, what all things are there. It's still in the development stage, but good enough for today, right? We won't complain about it. And let's just see what is there for us today. So first of all, this is a 4-stage rocket. This is a Vikram 1 test flight going to around 250 kilometers, 450 kilometers, 60-degree inclination. It has a payload capacity of 350 kilograms. First of all, this is India's first privately built rocket which is going to the orbit. There have been previous attempt which in which they launched the Vikram S rocket, but it was a suborbital flight. This one is totally they are targeting for an orbit, and that too will be a huge milestone because this will make sure that multiple things are accomplished for today. So there are like multiple things which we're going to talk about, but yes, this is a small launch vehicle, private launch. The company name is Skyroot, the rocket name is Vikram 1. Let's see the parts of this rocket. Click on this, and there you go. How cool is that? So first of all, this is a 4-stage rocket. You can all see that. We'll see about the first stage. So talking about the first stage, which is this one. This is the Kalam 1200 rocket motor, which is being used. This is a solid rocket motor, uses HTPB as its fuel. Around 1.7 meter is its diameter, and it produces a thrust of 1200 kilonewtons, which is so cool. And this is like all the 3 stages. First of all, are a solid, and then the fourth is the liquid. And they have gone with this configuration because this is easier to build, maintain, and then they can go more furthermore for increasing the payload capacity with their future missions. So this is the first stage. Then we have an interstage, which is this adapter, which has a pneumatic actuator to push the rocket. Then we have the second stage, which is again an HTPB solid rocket motor. Uh, yeah, solid rocket motor. It produces a thrust of 250 kilonewtons and runs. There is, yeah, it is ignites at around 55 kilometers altitude after a brief unpowered coast from first stage separation. Then we have another interstage. Then we have another third stage. Kalam 100 produces 100 kilonewtons of thrust and gives it a final push to the orbit. Basically, this makes sure this thing is in the orbit, the third stage, mostly like not fully in the orbit, but mostly in the orbit, because after that we have our fourth stage which comes into picture, which is a liquid fuel stage. And yeah, this is the liquid one. It uses Raman thrusters, so it has this one engine, main engine which you are seeing is the Raman 2 engine, and then we have these four thrusters which occasionally fire are the Raman engines only, but for with a smaller thrust for that. And they also works on monomethyl hydrazine and 204, all that stuff is there. So it's a normal engine, kind of, you can see the similarity between PSLV and this. There is just missing a Vikas engine and a liquid stage here, but yeah, you get it. And then we have a payload adapter. So this is how it looks like. This is the fairings, you can see that. So these are the four stages of the rocket. Now we'll just quickly talk about the um, I will just quickly talk about uh, the payload which it is carrying. Okay, so let's just change that. There you go. All courtesy to ISF, ISRO Spaceflight, for providing our things for the payloads capacity and payload information. You can just go and check them on the Twitter. These guys are great. So talking about the payloads, I will be taking that reference, and that means we have one payload which is going on this. There are actually six payloads which are going on this flight. First is this one, which is known as the um, Solaris S3 by Graha Space. It's a Bangalore-based company making a nano satellite constellation that will allow Earth observation via real-time 5-meter resolution. So that is one thing. And in this mission, they will test the satellite bus and other subsystems. They will also open source kind of this signals coming out of this satellite, because amateur, all those amateur satellite enthusiasts, they can read it. Talking about the next one, this is an interesting one. This is an Embrace by Cosmos Space. This is a robotic arm tech demonstrator payload, which will be bolted on the Vikram one, and it is again, all these things are developed by India only. Uh, and this is used for the active space debris removal application. So these are the arms which will, they want to test whether how these works in space. So they are bolting it onto this rocket. And how this works, look at this video. Okay, there you go. See how this, it will just hug the satellite in the orbit and then just deorbit it. So this is a debris removal one, which is very nice, because there are very few rockets, sorry, space companies, satellite companies which are doing it and coming it from India. This is next level by itself. Then after that we have um, um, Germany-based spacecraft known as D Cubed. This is a micro pin pooler. Basically, they are going to check the separation system. They have developed a new separation system which they are going to test. And then we have, yes, looks amazing because it is amazing. It is known as the Cosmic Bloom by Cosmos Diamonds. It is a synthetically developed diamond which is going to be carried to space. There are actually two ornament payload, but this is one of those. This is a synthetically developed diamond in lab, and it is also having this one, which is an 18 karat gold rocket containing tiny micro sculptures of Dr. Vikram Sarabhai, C.V. Raman, APJ Abdul Kalam, all the three trio of, you know, what should I say, the founders of Indian space science, right? I would say the establishers of Indian space science, not the founders, I would say establishers. Um, so yes, these are the cosmetic payloads, but always gives us a good, you know, thing to ponder upon when all these things comes. Then we have last payload, which is scoped by Skyroot themselves, and this is interesting one because if you can see, there is something called a camera over here, and yes, this they have not released any information about it, but they are going to, what they have released is they will going to collect valuable flight data and valid onboard systems, validate onboard systems. And I'm telling you, we are going to get very cool images and videos out of this rocket, out of this satellite, because we are going to get a third person POV mostly. Like what I hope that is the case, that because that would be amazing. Which we used to get in uh, uh, our which we used to get in the Chinese space flight, right? Okay, so talking about another. Yeah. So let's just quickly talk about their. This mission is known as the mission Aagaman, which literally it's a Sanskrit word, translates to arrival in English, which means arrival to space, right? A very nice name to go with. It has 450 kilometers target orbit, 60-degree inclination. It will. Okay, yes. The launch site they are using is the ISRO's Sriharikota only. They haven't developed their own launch site as of now, but obviously there will be few. They will be having future plans for the same. It has 350 kilograms to low Earth orbit, and it has three solid stages and liquid OAM, which is orbital adjustment module. Then we have all we have talked about this, the flight sequence, liftoff, safe clearance of the launch pad, pitch maneuver, max Q, then stage 1 separation, Mark 5, stage 2 ignition, payload separation, the stage 3, stage 2 separation, stage 3 ignition, stage 3 separation, OM ignition, and then OM cutoff, orbit injections, and the payload deployment. So this is how it is. Yeah, so that pretty much covers it. Let me check other things. I also have other things for you. Don't worry, guys. Just stay with me. There are few surprises coming up. Um, what else was I talking about? Yes, talking about this rocket, right? This rocket is very unique by itself because there are certain things they for the fourth stage they are using a metallic bladder basically. So fourth stage is a liquid stage and they will be operating it in vacuum. So how the fuel will stay at the bottom of the tank so that the fuel can go to the engine. So they have a very new technology, very unique technology known as metallic bladder, which actually pushes down the fuel to the bottom without any need for any thrust. So usually, if you see when a engine starts in space, they first of all uses those RCS thrusters to push it a little bit. After that, the engine start because the fuel comes into the bottom and then it works. But here that is not required because there is a metallic bladder which constantly pushes it to the bottom and then it works. So there are multiple such things which are there in this rocket, which we will be talking about very soon. But we have our, I think the stream coming up. So I'll be switching over to that. Yes, Andrew, been a minute, haven't been getting notifications from your channel because I haven't streamed for so long and you are here because and you are seeing certain improvements as well as my background. This is a whole new house, everything is different here. I have made these animations for you guys, this rocket explorer, so that I can show you. I'll be adding more rockets. Okay, I'll show you a glimpse of this. PSLV rocket is almost ready. So look at this. This is how the PSLV rocket looks like. And all this stuff, whenever these launches are going to come, we will be having a very good blast on this thing. Currently, we are just looking at this one. But yeah, this is all for you guys so that you can see this is developed by me from scratch. And any new rocket launch comes up, I'll be adding more rockets to it. Hi Pi, all the new older subscribers are back, right? So yes, I've developed this thing, Rocket Explorer, for all you guys to actually see and understand, so that you guys can understand. This is a part of Rocket Gun 2.0, which you're going to see a much more advanced, much more capable, much more frequent, much more having many more cadence of live streams and videos. But yeah, that's how it is. So let's move on to the stream which is going to happen. So before that, let's just yeah, I'll just move on to the stream and just get ready for the surprise, which is oopsie doopsie. And there you go. Oh, not coming up. Wait, it has been happening since long, but I have high hopes it will come up. Let me just fix this thing. I think it got confused. It will be fixed now. Okay.
Technology that just goes into a museum or the history books. What we are trying to build is a long-term, reliable, and sustainable business to meet the demands of the future space economy. And for that, I think Skyroot, the business team, and our customers are going to start with the low Earth orbit, but we are ready to reach the stars.
Every conversation I've had today has been different, but there are a few people who have had a front row seat to this entire journey. Now let's hear from them.
It has been a great journey. I saw engineers run through lakhs of simulations and hundreds of designs and configurations to make an optimal vehicle design.
Seeing so many passionate people joining us to build something incredible, not only for us, but for the nation. Interacting with them day in, day out, grooming their talent, nurturing their growth, makes this more than a job.
You know, the story really isn't about the rocket. It's about a generation of Indian entrepreneurs, builders, and dreamers and their potential. The rocket just happens to be a proof of that.
Skyroot is frontrunner in India's new space ecosystem, and our launch essentially signifies that the ecosystem has matured to a level where it can produce products and services that can compete well on an international arena.
Attention to quality is top-notch in rocket science. Our engineers spend thousands of hours in validating, testing, which generally go unnoticed, and people only see the outcome of the launch.
Foreseeing things and to handle schedules, permissions, allocations, etc. is what we are prepared for.
The fact that we are at the launch pad is a great milestone in itself, and my phone has been ringing non-stop. For the customers who signed up with us, it signals confidence. And for the prospectus, they're experiencing this mission with us, and I'm excited about the conversations that happen tomorrow.
Whether they have been here for years or just have started, one thing has been common in every conversation I have had. Everyone's hoping for the very best for this mission.
I'm really hoping that everybody who worked on this watched their dream lift off to success.
I'd love to see today's data confirm everything we've spent years designing, testing, and validating.
Here's hoping and wishing that today marks beginning of many successful launches and great partnerships with our customers across the globe.
I wish our mission is successful and all our hard work pays off.
My wish is simple. Everything we have prepared for last few years comes together seamlessly.
I wish Vikram 1 to be a huge success and make India and Skyroot proud.
Here's hoping today's launch provides us the required learnings to attempt more frequent launches and build much bigger rockets.
I would really like everyone to soak in and enjoy this moment.
I hope everyone feels proud today.
I hope everyone sees a little bit of themselves in today's launch.
Hey guys, it was all worth it.
And as we all say at Skyroot, our people are our thrust, and you are the thrust which made this happen. Let's all work together and create all the out-of-the-world milestones going forward.
Today also features a few guests whom we've invited to witness this launch with us. So let's hear from them.
And there you go, Shooks is here.
Namaskar. I know today is a landmark day. Skyroot stands at the cusp of their first orbital launch. Not just Skyroot, India stands at the cusp of their first orbital rocket launch from the private sector. Being a test pilot and then an astronaut, I know maybe a little of how it feels. How does it feel when you are trying to validate your years of dedication, preparation, and hard work? I know a lot of you would be anxious. A lot of you would be excited. But I would urge you to choose excitement.
There you go.
To me, I feel that this is a defining moment for India's private space ecosystem. A rocket launch to orbit is just a symbol of the rising aspirations of India as a nation in the space sector. And I wish the team the very best.
Yes, Smoky Sally, I am back.
Launched shortly, and they will be setting up that benchmark, and it's very heartening to see that they are opening their account with a launch of Vikram 1.
So I'm really excited to see what Vikram 1 will do for our space economy.
This is really going to change the sector in a big way.
Wish you all the success as we move forward from the first launch to dozens and dozens of launches that will follow very soon. All the best.
On behalf of the Department of Space, let me extend our heartiest congratulations to the young Skyroot team and also my team members who have supported this activity.
All the very best to you and keep working hard to achieve all your dreams. Thank you, and once again congratulations to the entire team of Skyroot.
Okay,
Vikram 1 is carrying more than hardware
let's
into
just-
orbit today. As this mission came
Okay, let's just talk about certain things. This is just an introductory video which we have already talked about, but that rocket which you see in the background is the actual rocket, you know. It's a full-scale rocket. You can see the things and stuff over here. The first stage is the first one on the left-hand side. Then we have the second stage, and then we have the interstage. And this is the payload, and we have the CEO.
Which we received from our team members, our investors, policymakers, and all well-wishers across the country. And we also have a very special card from none other than our Honorable Prime Minister Narendra Modi ji. And reading this gives me goosebumps. He has written Vande Mataram. And all these cards are going to go to space on Vikram 1 Aagaman mission, and very excited to send them to space.
There you go.
Every postcard the vehicle has on board carries a name, a signature, and a wish.
The Skyroot team has sent in their cards too. Their words are going to space on India's first private orbital rocket.
And now is the moment we all have been waiting for.
We are about to hand you over to Sriharikota, where the launch team has been through the final checks the previous night. Vikram 1 is finally ready for liftoff.
In just a few moments, you'll be watching a private Indian rocket attempt to reach orbit for the first time from the first launch pad and from Indian soil.
Thank you so much for being with us, and our team at the spaceport will join you live soon. So, stay tuned.
And we are just going to see the stream, guys. Historic moment. There you go from the mission control. I won't say mission control, but the commentary box.
Hello, and a very warm welcome
And
to
they have
everyone
updated
joining us
certain
from
things.
across India and around the world. I am Suyash Abhay-Ghirnikar, a program manager for liquid propulsion team at Skyroot Aerospace. And we're coming to you live from the Satish Dhawan Space Center at Sriharikota, where the countdown is underway for the maiden test flight of India's first private rocket, Vikram 1.
It's really wonderful to have you with us for what promises to be a truly historic day for India's space sector. I am Vaidehi Bhoyer, an aerothermal engineer at Skyroot Aerospace. Vikram 1 embodies years of focused work spread across 15 plus cross-functional teams at Skyroot Aerospace. And sitting here in MCC, we are extremely thrilled to see it stand on the launch pad today.
जी हाँ, यदि आप अंतरिक्ष विज्ञान में रुचि रखते हैं या
There
आप
you
एक
go.
विद्यार्थी हैं या बस आज इस मिशन को लेके उत्सुक हैं, तो हम अत्यंत आभारी हैं कि आप इस समय हमारे बीच सम्मिलित हुए। मैं अखिल तेलंग, स्काईरूट अंतरिक्ष विभाग में घूर्णी यंत्र अभियांत्रिक आपका हार्दिक अभिनंदन करता हूं। और बस 30 मिनट के अंदर हमारा ये सारा परिश्रम उस क्षण में परिवर्तित हो जाएगा जिसकी हम सबको प्रतीक्षा थी, विक्रम 1 का प्रक्षेपण या लिफ्ट ऑफ। अब हमारे समक्ष मिशन नियंत्रण केंद्र के अद्भुत दृश्य दिखाई दे रहे हैं, जहां पर विभिन्न प्रकार के विभाग अपने अपने प्रणालियों का संचालन कर रहे हैं। और इस प्रसंग में हमारे साथ डॉक्टर जितेंद्र सिंह जी, माननीय मंत्री, स्वतंत्र प्रभार
There you
विज्ञान और
go.
प्रौद्योगिकी तथा अंतरिक्ष विभाग, मिनिस्टर ऑफ स्पेस
Mission
भी जुड़ने वाले
control
हैं।
room.
और यहाँ स्काईरूट दल का उत्साहवर्धन करने के लिए
And this is
हमारे साथ
actually
डॉक्टर
the
पवन
ISRO's
वनिका जी,
mission control
माननीय
room,
अध्यक्ष भारतीय
because that's ISRO is supporting this launch. They are using their the launch pad from the Sriharikota. So that's why you can see the control room, which is of ISRO and many other folks. And there you go, the rocket itself. It's in cloudy. It's been a little bit weather conditions does not look so good, but I am hoping it will fly anyway, because this is a solid rocket booster, solid rocket one. The booster is the solid rocket one, and because of that, it has higher tolerations and limits for the weather. I hope that is the case, and we get to see the launch today. Everything is looking green because you can see the faces. He's the chairman of ISRO, and there have been multiple things on from the ISRO side as well in the past few months, past few days. Oh, we have Somnath sir. We have all the past ISRO chairmans over here. Radhakrishnan sir. Everyone is here. We have generations of talents just sitting over there. Wow, that's so cool. And this is the folks from the Skyroot Aerospace themselves.
विक्रम 1 इस समय प्रक्षेपण मंच पर स्थित है और अपनी प्रथम परीक्षण उड़ान के लिए तत्पर है। किंतु रॉकेट के बारे में जानने से पहले आइए जानते हैं स्काईरूट की कहानी। तो स्काईरूट एरोस्पेस स्काईरूट एरोस्पेस की कहानी हैदराबाद से प्रारंभ होती है, जो पूर्व भारतीय अंतरिक्ष अनुसंधान संगठन के 2 वैज्ञानिक पवन कुमार चंदना और नागा भरत ढाका के एक साहसी विचार के साथ जिसकी स्थापना की गई, जो था अंतरिक्ष को सबके लिए सुलभ बनाना या ओपनिंग स्पेस फॉर ऑल। आप सभी इस यात्रा का काफी समय से भाग या हिस्सा रह चुके हैं, तो अपने अपने अनुभव के बारे में थोड़ा दर्शकों को बताइए।
Although it does not
Right,
look
Akhil.
so
Thank you for
good,
asking
but
that.
yeah,
So
it's
back
fine
then in
for us.
2018, when I heard about Skyroot, it was really a mix of excitement and curiosity. For decades, India had looked up to ISRO for every space milestone. India's space sector was opening up to private participation, creating room for companies like Skyroot to innovate, build, and contribute to the nation's growing space ambitions. Here was a private company which came out of nowhere, and it said, we
There
are
you have the
going to
launch
build
view
an orbital
gallery.
launch vehicle from scratch. On immediate thought, it looked like this is going to be extremely difficult. But if anyone succeeds, it could actually redefine India's entire space ecosystem. It felt bold, it was quite ambitious, and the timing felt quite right. Suyash, what did you make of it?
Yeah, Vedi, it was pretty mind-blowing to say the very least. When we first heard about this, it was extremely exciting. One question that we asked ourselves is, we have such a grand vision, but what do we need to do on ground before we can aim for stars? So one thing we realized very early on is every critical piece of technology that we need to fly, we need to test in-house, we need to build in-house. And I got the chance to help build a lot of these technologies. So me with a small team of very ingenious, multidisciplinary engineers, we essentially helped build the liquid stages on this vehicle. And working from the ground up, designing and testing the upper stage, the RCS module, sort of taking it from cradle to grave was a once in a lifetime opportunity that
And
we
there
knew
is a
that
launch
we
control
had to
center
capitalize
of
on.
the Skyroot themselves.
Like
I think that is not inside the ISRO, or is it? No, because all the systems and the monitors are in different here.
And
So
now
this is
in like closer to
somewhere
20, we
else,
had
mostly in
Skyroot
the
Sunday,
Skyroot
and in
headquarters.
2026, India finally has its first space tech
Yeah, this
unicorn,
is different.
and almost close to
We are
350
T
plus
minus
space companies.
31
So
minutes
I
and
think it's
15
apt
seconds
to
from
say
the
that
launch. Everything
Skyroot
is
has
looking
pioneered
green
India's private
for
space
the
ecosystem.
launch itself.
Yeah,
People
that's
are
true.
currently talking
And
about
this
there, and
recently you
yes, it's the
will be
launch
seeing
day,
views
30
from
plus
the
minutes to
launch
launch.
control center
We have
at Skyroot, and
everyone
now
from ISRO. You
yesterday
can
through the
see all
mission
those
control
folks,
center,
all the
where we
chairmen,
had
past
a
chairmen,
lot of
whosoever was
dignitaries who
available
joined us.
has come
On
to
your screen
see
right
this
now is Dhawan
historical
and Bharat,
achievement of India's
and of course
privately
Sanjay as
developed
well, our
rocket
mission
going to
director.
space.
So one of the things
Hi
that Atul
NSS
just mentioned
Datta, I
is
am
that it's
doing good.
pioneering
Finally,
the
it's good
space
to be
ecosystem.
back. And there are a lot of
One
things which
thing
are
that
going
comes
to
about
come. But
is
yes, this is one of
the
those. You
space
can see
market
those
is growing
animations.
just as
This will
rapidly.
accompany the
Space
rocket launch
has
today.
quietly become part of our daily
And
life.
yes, things are looking
Every
good
weather
for now.
forecast that you look at, every map that guides you home, digital payments that you make every day, long
Right
distance calls.
now, okay, let's just talk
Each of
about
these have
certain
a satellite
things about this rocket, certain facts about this rocket, since we are having some time, which I wanted to talk about anyway. So let's just talk about that. First of all, this is an fully autonomous rocket. So the rocket is fully autonomous, handling everything from the pre-liftoff sequence to the payload ejection. Everything. It's fully autonomous, and it has for the roll control and for pitch and yaw maneuver, it has actuator systems to steer the rocket, and it uses electromechanical actuators, which basically flex the nozzle of the rocket, and hence provide those steering capacity. They also have a very highly sensitive laser gyros in the inertial measurement system, which is again very cool. And then talking about the engine, I was talking about the Ramen 4 engine that is fully the Ramen 2 engine, which is fully 3D printed basically. It's a 3D printed engine, and it's there to increase the launch cadence, easier to make, easier to manufacture, minimize joints, and all those things are there. And the rocket is built using high-tech carbon fiber composites, which is capable of withstanding 1500 degrees to 2000 degrees Celsius of external temperature, which is amazing. Talking about the separation system, they use the pneumatic separations. Unlike the traditional rockets, which using pyrotechnic charges, they use a pneumatic separation system, which just separates the rocket from their stages by pushing it. Then another thing different about this rocket and PSLV is that it's a monolithic booster, which means you don't make or manufacture the solid rocket booster parts in parts in stages and then combine all of them. That does not happen. This is a fully combined, a full ready to use booster, which is used in the launch today. If you have seen PSLV, they assemble all those parts together and then make the full solid rocket booster. Here that does not happen. It's a monolithic structure. Again, the decision is to simplify the architecture. It does not need that much of much of that many parts, I would say, because it's not that big of a SRB which is there. But again, this is a biggest SRB privately developed by any company all over the world. So that is one thing. Another thing is, as I already told about, is the metal bladder system in the fourth stage, which allows it to in the fourth stage, in the vacuum, since it will work in vacuum, it allows that bladder allows the fuel to be at the bottom, so that the engines can start and work. And then finally, there are many things, and the attention to details which are there. The founders emphasize that the rocket is a system of systems. That's what they go with, which allows them to pinpoint certain things, pinpoint how the things will go, what will be the testing mechanism and all that stuff. But yeah, finally everything is done. We are T minus 26 minutes 45 seconds from the launch. And you can see the rocket on the launch pad right now. Everything is looking green. Let's see how it all works out. Let me just update the timer.
Aagaman is derived from the Sanskrit word meaning arrival, and it's sort of twofold. The first is it's the arrival of India into a new space era, wherein the private sector takes a huge leap and delivers and caters to the global launch market. But secondly and importantly, it's the arrival of a new launch vehicle, a very capable launch vehicle to the launch market and help meet some of that global demand. Now, something pretty cool about today's date, and I assure you it's purely coincidental, and it's kind of amazing really, is 46 years ago today, India's first indigenous launch vehicle, SLV, reached space and placed the Rohini RS-1 satellite in orbit
Wow.
and kicked off India's space ambitions. And coincidentally, again, 8 years ago today, Skyroot began its journey as well to open space for all. So it's company day today as well.
अवश्य सुयश, इस जानकारी को दर्शकों को प्रदान करने के लिए आपका धन्यवाद। अब हमारे समक्ष हम देख सकते हैं
Hey Mars, yes,
नियंत्रण केंद्र के प्रत्यक्ष दृश्य जहां
their chat is a mess. That's why you came here, right? This is a clean chat over here. But yeah, a long time no see. Talking about myself also, there was I was between things, had certain on and off phases in my life, but now I was like I have to come back, and this was a moment where I have wanted to come back. So this is what you are witnessing today is Rocketgyaan 2.0. You can see the animations have changed, the explorer is there, all that stuff is going to come even more, videos will going to come even more, so you are going to see much more of me in coming days. I'm not going to leave you. You're going to see this face again and again every day from now on. So that is the case. T-minus 24 minutes from the launch, and everything is looking good. Yes, right, Andrew. That's why the booster is separated into stages. In this case, we have three stages of solid rocket boosters only, and all that stuff is managed, basically all the simulations and everything. And just a disclaimer, guys, this is the first launch which is happening, okay? And this is the first launch, and we have seen how the first launch of the privately owned companies go. We have Astra example, the Rocket Lab, the SpaceX, all those fails. Everything fails. Everything goes away. But will this be an exception today? That is one thing which we have to see. And we are going to witness whether the Skyroot and their Vikram 1 rocket become the first successful rocket from India to reach the orbit privately, and whether it will be able to reach the orbit in its first attempt. That is the main question. Yes, it is using SRB, yes, it is using easier engines, but that's no excuse for the space, which is very, very hard to reach and go. So we all are hoping, and especially from India, where privately and the space, and I'm talking about India specifically, the space and the rockets and the space science, space tech is highly inaccessible. These founders, I have kind of conversed with them, and I know how hard they work. That's why I know how difficult was for them to even ideate the idea, get the right people in right place, and then finally do the right thing, which is launching the rocket finally. So that is the thing. Yes, Mas, you are right about it. First launches rarely go well, and I'm hoping, but I'm very confident, to be honest, this will go well. Because the folks who have developed this rocket, I mean the engineers and all that stuff are all those people are there, but people do forget that we have retired ISRO engineers, ISRO scientists, which are actually working in Skyroot to help them achieve this dream, in the board of as consultants, board of directors, all that stuff. And that is what is followed now by Agnikul also, because Somnath sir, which you can see in these photos and glimpses, is here, but he is now the board of directors of Agnikul Cosmos. So I'm hoping that the the things changes for Agnikul as well, as we can see for Skyroot.
Air or space, we can say, it has unconstrained 6 degrees of freedom, out of which like 3 are straight line motion, or let us say translational, in which it can move forward, backward, upward, downward and sideways, and 3 degree of rotation are rotational, which we call as pitch, yaw and roll. So these are the 3, or let us say mechanisms that are like, we can say, help in steering the rocket engine and the entire vehicle in the sense.
That's right, Akhil. And I believe different parts of the vehicle handle different pieces of that. So on the way up, the solid rocket motors steer in pitch and yaw by swiveling their nozzles. Roll, which is the spin around the rocket's own axis, is handled separately by a small dedicated liquid system during the climb. We have a set of 4 thrusters which fire in pairs to control the roll of the vehicle. And once in space, OEM does its own point pointing with the help of small thrusters, which Suyash will tell us about.
Yeah, so on the OEM stage, on the periphery of the stage, we have what we call as Raman mini thrusters. So they essentially generate 50 newtons worth of thrust, and they help in attitude keeping, which is essentially making sure that the spacecraft points in the right direction. So that covers the pitch and yaw. What do we do about roll, one might ask? So we have like these small cold gas thrusters. They're placed along the periphery of the stage as well, and they fire in pairs. So with that, they're capable of generating a rolling moment to roll the vehicle. Now, this whole architecture that we talked about, it's something that answers purely to the requirements. It's powerful where it needs to be, and incredibly precise where accuracy matters the most. And this is a philosophy that we've extended beyond propulsion. So all our structures on the rocket are made out of carbon fiber. This is India's first launch vehicle which is made purely out of carbon fiber, and it's 5 times lighter than steel. We also employ advanced propulsion technologies. All our liquid engines are additively manufactured or 3D printed, and all of this, what it contributes to is it reduces the weight, it improves performance, and also increases manufacturing efficiency. The net sum of all these decisions is you have a rocket which is reliable, on demand and affordable.
That's true, Suyash. So an update for our viewers, just a while back we got a confirmation that the guidance, navigation and controls team, they have successfully completed gyro compassing and the static navigation profiling of the lens package. This is done so that the rocket knows its initial orientation with extremely high accuracy. In the process, the inertial navigation system determines the initial attitude of the vehicle by identifying the true north and the gravity direction with respect to a rotating Earth reference frame.
Wow.
So quite unique it is.
That's true. And it's something very important.
Talking about this inertial system which they talked about, as I told you, they use a highly precise laser inertial system to measure all those stuff.
You want to know where north is so that you can chart your journey accordingly.
जी सुयश, और आई थिंक वायुयान में भी इसी सिद्धांत का प्रयोग किया जाता है और वो उसी सिद्धांतों पर निर्भर करती है। तो यदि अब हमको ज्ञात है कि रॉकेट किस दिशा में जा रहा है, हमारा विक्रम 1 प्रक्षेपक यान, आज की इस पूरी यात्रा का लक्ष्य क्या है, वो किस ओर प्रस्थान करेगा?
Today's test flight is attempting a 450 by 450 kilometers circular low Earth orbit, or LEO, a region of space widely used for Earth observation, communication and technology demonstration. But this is a maiden test flight. So what matters most today are the fundamentals. Today's test flight has 3 prime objectives: executing successful stage 1 ignition and liftoff, clearing the launch tower safely, and then gather as much data as possible from our onboard sensors.
अवश्य विदय, जैसे आपने कहा कि ये एक प्रथम परीक्षण उड़ान है, इसीलिए आज सबसे अधिक महत्वपूर्ण ये है कि अभियान के प्रमुख उद्देश्य को हम जान लें। प्रथम चरण का सफल प्रज्वलन, यान का सुरक्षित उड़ान पथ से निकास और अधिक से अधिक उड़ान अंकों का संकलन। किंतु अंतरिक्ष तक पहुंचना अत्यंत महत्वपूर्ण है, ये हम सब जानते हैं, बट सही कक्षा में उपग्रहों को स्थापित करना एक कठिन कार्य है, राइट?
That's absolutely right, Akhil. It's not sufficient to just simply reach the right altitude. The rocket must inject the payload with the correct velocity, the right flight path, and the precise orientation so that the satellite begins its mission exactly as planned.
Yeah, that's right. Now that we know where Vikram 1 is headed, let's talk a bit about what it's carrying today. So, what's on board today's mission?
Vikram 1 is carrying two deployable test satellites today. The first one is Scope, a test satellite developed in-house by us as a technology demonstrator. Joining Scope on today's mission is Solaris, a CubeSat developed by Graha Space, flying again as a technology demonstration payload. And from Germany, D-Cubed is testing two of its own systems, deployment and separation technologies built to work in orbit.
And there is one more interesting payload that we have is from Cosmos Space, and it's flying soft robotic arms along with the OEM stage that will attempt to capture a piece of simulated debris in orbit. That is a very interesting thing that they're attempting indeed. And it stays mounted to Vikram 1 throughout the entire flight. And if it works, it will be the first of its kind to demonstrate this kind of a experiment. And it's an early step to clearing the space debris in general. That's a great initiative, I think.
Yes, definitely. And there's two more payloads on board, ones that celebrate creativity and India's scientific heritage. The first is Cosmic Bloom, a delicate floral diamond artwork from Cosmos Diamonds. The second is quite something else entirely. It's a micro art, an 18-karat gold rocket crafted by Telangana artist Ajay Kumar Matewada, holding three tiny sculptures of Nobel laureate Sir C.V. Raman and visionaries Dr. Vikram Sarabhai and Dr. APJ Abdul Kalam. Each one of them is smaller than a grain of rice, and it's a fitting tribute because all these three names essentially live aboard Vikram 1 itself. The Raman engines, the Vikram 1 vehicle, and the Kalam motors. Now, as we count down, of course, it's worth taking a pause to appreciate where this journey is beginning from. Vikram 1 lifts off from the first launch pad here at Satish Dhawan Space Center at Sriharikota, more familiarly called as the Shar Range, a place that has witnessed some of the most defining moments in India's space program.
That's correct, Suyash. This very pad has a proud history and legacy of its own. This is the exact place where Mangalyaan set off for Mars in 2023. And Sriharikota itself has launched India's greatest space journeys, like Chandrayaan to the moon, Aditya L1 to study the sun. And now, our very own Vikram 1 adds its own chapter on its journey to the stars.
That's right, Akhil. Missions like Vikram 1 are helping position India to serve the fast growing.
All right, let's just talk about certain things. We are right now T minus 30. If you are just joining in, guys, let me just brief you about this mission. We are T minus 13 minutes from the launch. Everything is looking green. Although the weather might look a bit off today, but this is an SRB, this is solid rocket boosters, which is being used, so don't worry about the weather too much. Everything is looking good as of now. You can see the size also, it's very small compared to PSLV, not very small, but relatively small. Kind of equals to SSLV, but I have to check the actual the numbers for it. But yeah, so we are the Skyroot is launching India's first privately developed rocket Vikram 1 to the orbit this time, not to space just, but to orbit. They are not going for a suborbital flight, which means they are not going to go up and then come down. No, they are going to go there to stay. This is their first attempt, so things can go wrong. This rocket is a 4-stage rocket. The bottom three stages are the Kalam 1200, Kalam 250, and Kalam 100. Each step signifies the amount of thrust it can make. And these rockets are the SRBs, solid rocket boosters, using STPB as its fuel. And then we have finally the 4th stage, which is the OAM, the orbital actuator module, which means it is a liquid stage engine running on N2O for an monomethyl hydrazine. This is it's using the same fuel which PSLV uses at the 4th stage. and it uses Raman engine, 2 kilonewtons of Raman 2 engine, and then it has 4 thrusters also of the Raman engines, modified Raman engines, which produces around 50 newtons of thrust, which gives its pitch, yaw, and anything which it has to do. It also has 8 cold gas thrusters on the upper stage, which the fourth stage, which is used for the roll control. Talking about the payloads, there are 6 payloads going, out of which 2 will be deployable, and there is, yes, a diamond, yes, a cosmetic payload of miniature statues of APJ Abdul Kalam, Vikram Sarabhai, and CV Raman, and also there is a payload from Skyroot themselves, which is which they haven't told about anything about it to us, but I suppose that is used for taking third-person POV of the rocket, calculate different findings, different data on the rocket itself. But yes, this is a rocket company, but they also developed a satellite. So this is next level. Is this rocket close to the size of Firefly Alpha? The size, the capability, not at all, because the payload capacity is 350 kilograms. And for the Alpha rocket, it's around 1,500. No, this is a smaller one. Smaller rocket than Alpha for sure.
Correct, Vaidehi. If any one of the many critical parameters that we observe during the entire sequence goes out of its normal expected bounds, then the rocket smartly aborts the entire sequence and initiates a preloaded set of commands, and that will safeguard the entire
checklist
vehicle.
is there.
And then the people stationed at the ground or the engineers can have a closer look, and if the issue can be resolved within the stipulated time, then we'll have the sequence back again and we can go ahead with the launch.
Yeah, that's right. This is something very useful to have, wherein engineers can resolve faults and understand if there's something that can be quickly fixed, and then we can continue back on ALS. So I think we were just talking about what the rocket does, and once stage 1 powers the vehicle for nearly 100 seconds, something important comes, which is max Q.
Right, you're right, Suyash. As the vehicle continues to pitch over and accelerate, it approaches one of the most demanding phases of ascent. Nearly 25 seconds into the flight after the gravity turn is max Q, the moment of maximum dynamic pressure. This is when the rocket experiences the greatest aerodynamic loads, a true test of its structural strength and engineering precision.
Yeah. So now we're at T-minus 9 minutes and we're entering another crucial phase of the launch countdown. The launch team is now carrying out a final series of vehicle health checks and making sure that Vikram 1 is fully prepared for flight.
Yeah, as we can see on our screens, one of the most key milestones at this stage has been completed. That is the transition from the external ground power to the rocket's onboard batteries. Up till now, the vehicle has relied on its own ground support systems, but from this point forward, every stage must successfully power itself. And engineers are closely watching the battery performance and electrical health to ensure that this transition is very smooth and every system remains entirely stable.
Right, Akhil. With the power transition complete, attention would shift to the rocket steering system. Engineers will now be verifying that the thrust vector control, or the actuators as we call it, the mechanisms which steer the rocket by precisely directing thrust through powered flight.
Yeah, I really liked what I really liked about their stream is it's highly technical. That's the thing. It has to be highly technical for the people to actually go into what's rockets and space science.
But it's quite simple. It's just the nozzle is capable of swinging in 2 planes, and the way we achieve this motion is by using electromechanical actuators. So you might imagine that this is something very important that we should check. So what engineers do is they perform something known as a null check. Essentially, they currently try to hold the nozzle in a neutral position, and then once that is confirmed, they provide small commands to the nozzle to deflect it, and if the response is deemed to be normal and the position is correct, we can be rest assured that the rocket will obey every command that is issued to it by the guidance computer.
Right.
Alright, live on your screens right now is the Vikram 1 rocket, and for a long time now we've been looking at these views, and the biggest thing that comes out to our mind is, wow, that's a marvelous piece of engineering, and it's actually rocket science, right? There's a nearly 1,000 systems that need to work in perfect synchrony just to make liftoff happen, and that's 2/3 of all systems on rocket. So 2/3 of all system on the rocket need to work perfectly to make liftoff happen. And while it's so easy to look at the rocket and be amazed by its beauty, we would like to take a small pause and focus on the fact that behind every bolt, every wire, every line of code that is on the rocket today, it's been built by people. People whose passion, perseverance, and dedication have made this moment possible. Of course, a launch vehicle is never built overnight, and it's the result of countless people obsessing over one thing to make it perfect.
Exactly, Suyash. We often celebrate rocket launches, but rarely appreciate the engineering complexity behind that. And the most primary guiding principles in Skyroot is our people are our thrust. So it's not just the rocket
Yes,
alone
Andrew.
that pulls the company
Units
up.
were
It's just the people
consistent
that pushing
for sure.
forward, pushing the entire
Although,
technology forward, and all the hard work.
It's not America. Here we know what to follow, right? Metric system and all that stuff. Americans have this issue with the unit systems conversion. Not Indians.
Mentioned earlier, rocket consists of almost around 1,000 independent subsystems, and they are deeply interconnected. A seemingly small error in one discipline can propagate through multiple subsystems and ultimately jeopardize the entire mission. Rockets operate with extremely tight margins, so local design inaccuracies rarely remain local. This interconnectedness is precisely what makes launch vehicle design both extraordinarily challenging and intellectually rewarding. Each deviation might appear acceptable individually,
Hold. We are at a hold right
but
now,
they
guys.
can also collectively they can all consume all the
We
design
are at a hold, guys, and it was expected. We are at a hold. T-4. Not planned. No, it's not planned. Something has gone wrong. That's what has happened. Not planned, bitch. Let me just fix this thing.
in front of the vehicle rapidly gets compressed, and just outside the vehicle surface will have extremely high temperatures which then get convected into the vehicle surface. So just a simple question, do you guys know like what is the heat flux which we face standing on the earth's surface due to the earth's radiation?
I think 1,000 watt per meter square, kind of. Am I right?
That's right, that is 1000 watt per a meter square. It's around 0.1 watt per centimeter square. When Vikram 1 ascends into the Earth's atmosphere, its nose tip can face around 15 watt per centimeter squares of heat flux.
That's pretty large. I mean, as compared to humans, if we, yeah.
That's right, that's right. And we really need to design a thermal protection system to keep the structural design under the set constraints. If we don't design any thermal protection system, the vehicle surface might end up going to 1500 degrees Celsius. And
yeah, so we just got an announcement. There's a hold at T-5 minutes. People are looking into what has gone wrong. And guys, again, remember.
All stations, there is a hold observed at T-5 minutes. All stations are requested to be on standby mode.
Right, it's on standby. So as they said, they use a automatic launch sequence. Okay.
That this is a planned hold, and we've been advised to stay on standby. We will communicate regular updates to you, so please stay tuned with us.
I don't know why they keep on saying it's a planned hold. It's definitely not a planned hold. It was 11:30 a.m. was the liftoff time. Something might have gone wrong, or something might have not checked out. That's why it's a hold. It's okay, but let's talk about the launch sequence which they use, which they say it as ALS, which is the automatic launch sequence, and it's kind of similar to what SpaceX has. They have a recycle timer if something happens, but now since they are using an SRB, they have little checks to play. Like in SpaceX Falcon 9, what happens? We have the liquid fuel rockets, that to cryo rockets, and if there is a hold or something, we have an issue of the fuel boil off, right? The amount of fuel which was needed at the time of the launch, it may not happen because of the hold when it again lifts off. So that's why they have an automatic they have a launch recycle, which is around T minus, depends on how long it has been holded for, and all that stuff are there. But they have a very checkpoints, and each I'm talking about SpaceX right now. They have checkpoints at each phase of the rocket launch, and depending on which one is nearer, they can recycle back to that particular point. The nearest they can recycle is, if I'm not wrong, is T minus 45 seconds if everything goes right, and then it can work. Talking about the Skyroot, we don't have as such the information about what is the recycle time of them, but I can definitely say it will be way lesser and way little what should I say, way simpler than SpaceX checklist, because they are using an SRB right now. They don't need to worry about the fuel top off. They don't need to worry about the fuel boiling off. They don't need to worry about engines being at the right temperature. All that stuff they don't need to worry about, because they are using SRBs in there. And so that is the case, and that's how it works. So hopefully, since it's an automatic launch sequence, everything is, as I told you, it's fully autonomous. Pre-flight checks, during the flight, and post-flight checks also, all that stuff is fully autonomous. So if they have to recycle back to certain point, they can definitely do it. They don't have to worry about certain things as such, the fuel going off, and that is not working or something like that. The hold right now might be due to some technical issues, and that what they are resolving right now. Hopefully they are able to resolve. So for the SRBs, you might be thinking, what is the hold they might be having? They don't need to worry about the cold temperatures, the engine checks, anything. All that stuff is not there. But yes, there are certain checks, as in the SRB has a flex nozzle in place. They use the actuators to steer the rocket, to steer that nozzle. They need to check that particular nozzle is working fine or not. They need to make sure the cold gas thrusters, and they have a roll control thrusters also for this, which are the modified Raman engines only, but they also utilize their own fuel. So they need to make sure all those things are in place and nothing is boiling up. The major advantage I won't say advantage, but kind of a simple thing they have is that they use earth storable liquids and not cryogenic liquids for their liquid fueled rockets and thrusters. Which means they can very well again, no need to worry about fuel boiling and all, evaporating and all that stuff. I'm just hoping, we are all right now hoping that it's just a minor issue, some valve, some pyros or something checks might have failed, and doing a restart or something will fix it. But since it's a first launch, anything can happen, anything can go wrong. They always do a dry launch sequence and all that stuff. But we are space nerds. We have been following the rocket launches for a long time, for us to see that this is very common in rocket launches. So we'll have to wait and see what is their update.
When in flight, it experiences combined effect of aerodynamic loads, engine thrust, wind gust, and due to different steering maneuvers, the teams or the designers deliberately give some flexure, or like they make rockets slightly less rigid so that it can actually bend along its length throughout the flight. This is intentional, that designing an absolutely rigid rocket would make it significantly heavier and less efficient. And it also creates a complex engineering challenge. As the structure bends, the onboard sensors can detect these motions, so the guidance and control system must distinguish the rocket's actual altitude and structural flexing to avoid unnecessary control corrections. And engineers carefully predict these bending modes and their natural frequencies through the structural dynamics and aeroelastic analysis, ensuring the vehicle remains stable even as it flexes its way through one of the most demanding phases.
Wow.
And this flexure could go up close to 10 centimeters, I think. Yeah, close to 10 centimeters. That's pretty huge.
Huge.
That's right, Akhil.
So again, it proves right, guys. The KSP is real. KSP wobbly rocket is a real thing that happens in real life. Oh yeah.
It might be difficult to imagine this, but people often imagine astronauts escaping Earth's gravity. The truth is, gravity never lets go. Even the International Space Station is constantly falling towards the Earth, but it's moving sideways at so high speed that it keeps missing the ground. And that's what we call as orbit.
Yeah, that's wonderfully put.
Orbit is a state of perpetual freefall.
Yeah,
Wow.
that's right. And you spoke about how astronauts on the International Space Stations are also constantly falling towards Earth. And with us today in the Mission Control Center is our very own astronaut, Shubhanshu Shukla. And he's been following Skyroot's journey from a very close distance. He's part of our family as well. And he's here to cheer us on. So we thank him for his presence.
Awesome. Yes, you don't start an SRB unless you really need it, right? Yes, they have tested the SRBs in isolation, but there are multiple checks that they...
For our viewers, that rockets get lighter every second. Unlike an airplane.
Yeah, so they have they must have done a dry run for this, but since the rockets are so complex, even though SRB feels a little less complex, but
when you have a rocket,
we'll be reinitiating ALS soon.
When you have a rocket, you
after
cannot
finalizing
have
on a T0.
Okay, so we have update from the mission control, which is the issue has been identified. New T0 is being currently identified.
Dealing with rockets.
So issue has been identified and resolved, and right now they're working to, you know, realize the new T0, which is going to happen very soon, and then finally they will reset the ALS system to the nearest recycle time. So that means we are go for the launch. Let's hope nothing else is in the way right now. The technical fault is resolved. That's so good to hear.
That is why rocket keeps accelerating, because there is less and less mass to push.
That's right, Akhil. A rocket may weigh hundreds of tons on the launch pad. Consider our Vikram 1, it weighs around 45,000 kgs on the launch pad, but nearly 90% of that weight is just propellant.
That's really amazing. That structural mass is so less. I mean,
Yeah, that's why it is so highly inefficient also, and that's why we need nuclear rockets. But people will, and I'm glad that Elon Musk is in space sector, because he will realize those nuclear rockets. And I'm telling you, nuclear rockets, nuclear propulsion will be highly common once we have base on the moon. Because there also we have water as the fuel which we can use, but once we are in space and we can manufacture nuclear rockets over there, then only we can actually be prepared for actually going and exploring the outer solar system. Because right now with chemical rockets, that is highly inefficient and takes a lot of time. With nuclear rockets, highly efficient, takes very less time. Everything is just it has advantages and advantages, but the issue is the nuclear. That's the thing. And when, as the president of America say, you don't say that N word in front of me, right? So that N word people fear. They don't want to make those things in public. People even in the public also, even though NASA and SpaceX, all those stuff, all those private companies may make certain nuclear powered rocket, but they will face high, what should I say, revolt and rebel from the local population because it's nuclear. So yes, people's general public awareness is also needed, but to actually excel in space sector, to actually go and explore and speed up our process, speed up our time of exploration, we really need nuclear powered rockets. All these things are very nice, SRBs and everything, but at least the upper stage, first of all, let's start with the upper stage. Let it be a nuclear powered rocket, then we can think about the nuclear powered SSTO, which is single stage to orbit. But yes, that's the case.
The hold that you observe on your screens was due to a hold raised by the navigation team.
Vehicle directed to launch control. Please do the needful pre-exercises to reinitiate ALS and confirm your readiness.
And we've gotten confirmation that we will be starting ALS shortly, so please stay tuned. So we had a planned hold, and we've just heard from the mission teams below that we are ready to restart the automatic launch sequence shortly. And just to recap once again, Vikram 1 is on the launch pad. It's ready and eagerly awaiting its first test flight. We've had the initiation of the automatic launch sequence, and through that we've completed the internal power switchover, which means the vehicle is now powering itself using its own batteries. We've also had the null checks been completed, and we're now waiting for the next window to come about for the ALS to restart.
So now that we know that the ALS is on hold and soon we'll be back with a new time and the restart of ALS, let's talk about the entire journey of Vikram 1, the mission sequence. Now we know that first 100 seconds of the flight, the stage 1 will power the rocket to the denser layers of the atmosphere, and exactly at an altitude of 53 kilometers at 103 seconds, the stage 1 burnout will happen and the stage separation will initiate. And after that, the stage 2 will ignite and it will power the rocket through the thinner layers of the atmosphere while keeping the same level of acceleration. That is the point. And later on in the stage 2, during the stage 2 burn duration, later half, you have the payload fairing and it separates, and this is the first time when the payload or the satellite is exposed to the atmosphere or to the space, the higher layers of atmosphere, which is exactly nearly close to space. Yeah. Having protected the satellite throughout the ascent, that the fairing's job is done.
Yeah, that's right, Akhil. And you mentioned that the PLF or the payload fairing is the portion that essentially protects the satellite from the difficulties of the environment.
Okay, also guys, I just forgot that I am wearing this hoodie, this sweatshirt, basically the one which is lucky for me, lucky for everyone. No launch has failed when I wore this sweatshirt. That's why I wore it again. Hopefully this mission will also be successful.
It relays very little shock to the payload itself. So the payloads usually carry very sensitive electronics and instruments. So if you have a shock event come about, it may damage some of the sensitive instruments. So that's why we specifically made it a point to develop this pneumatic ultra low shock separation mechanism.
Like, for the knowledge of our viewers, I would also like to reiterate, most typical rockets, they use pyrocords, which use explosive charge to shear out the bolts and separate or jettison the entire stage, which could be catastrophic for some sensitive payloads. That is very costly and could be like, you might lose some data from the satellite and affect its workability.
Control here, go ahead.
Definitely.
Still external hold mode is coming.
Right.
Noted.
Now, even after the payload fairing has separated,
launch
the job
control.
isn't done yet, right? The climb is
Please
still
release external
going
hold.
on. Stage 3 steps in and it generates quite a
launch
large
control
amount
two
of
controls.
thrust
External hold
to
release.
essentially power the vehicle
Roger.
into orbit. It keeps pushing it to near orbital velocities.
Control.
And then
Request
comes
MCC
something
to
different,
release the
like we
hold.
talked about earlier. We have the orbital adjustment module that kicks in. And this is the stage that I got to work on very closely. Like I mentioned earlier, it was a team of very ingenious, multidisciplinary members. We had teams from systems, propulsion,
Timing, you can
dynamics,
set the revised T02
quality,
12:05,
safety,
30 hours
reliability, CFD, design. I mean, you cannot count these fields on the fingers of your hand, and they all had to work in unison
Control
to
to all ground
build
stations.
this stage.
All ground stations to
And
note.
then once
Revised
it starts
T0
working,
is
it
at
will precisely
12:05,
place
30 hours
all
IST.
of these satellites into its intended orbit. And you might feel like all of this is happening. There's so many things happening, right? But it's just 16 minutes. That's all it takes. It's
T minus 20
fast,
minutes.
but it seems really long. Like it took us like 1 hour from the entire bus stand to reach Sriharikota. But as Suyash pointed out, so it's such a we can say the entire rocket engineering, the complexity. Looking at the complexity of it, it's like an entire opera house. You have to be like a soprano. You have to be so perfect. Every system, every individual, and every component
There you
should be
go.
in.
So
tune.
we have, guys, the updated T0. We are targeting 12:05:30 IST hours. If you haven't if you are just joining in, guys, let me tell you, there was a hold. There was a technical fault which happened from the navigation team. They were not ready, and the navigation might be throwing some errors or something, but and those errors have been resolved. The new T0 has come up. Previously the launch liftoff time was 11:30 a.m. now it 11:30 a.m. now it is 12:05 p.m. We are right now T minus 19 minutes from the launch. Everything is going good. We had a hold at T minus 5 minutes, but now things are resolved. Everything is going good, and we are just waiting for the India's first privately developed rocket to lift off from the ground and to the orbit. And this is their first attempt, so many things can go wrong, many things can go right. Let's hope they go right only. And we have all the chairman's astronaut also, Shok's here, India's astronaut who went to ISS in one of those crew missions, Crew Dragon missions. So yeah, we are 18 minutes from the launch. Everything is looking good. We're
hearing from the mission control that the new T0 time or the liftoff time for
T-minus 18
mission
minutes.
Aagaman is reset to 12:05 p.m. So stay tuned. We'll be with you and we'll give you some more space trivia. We have a lot of those, and we'll also take you through the journey of the rocket as well.
There you go. So T minus 17 minutes from the launch, things are looking good. Guys, just tell me, how do you like the animations and everything? It will be there to help you, because I am definitely sure we are not getting any good animations on this. Because it is broadcasted by DD. This is the issue with the Indian space, especially the rocket sector right now, that it is highly controlled by ISRO and their foundations and how they operate. Once it is the private sector is fully independent, right now they obviously need ISRO to actually excel and make sure they don't fail again and again, so they are going with it. But once they have their own launch pad, own launch control center, everything on their own, I'm pretty sure we're going to see an improved quality in the live stream. We are definitely seeing an improved quality, being it a private launch vehicle, because the technical discussions which they are having is really phenomenal, which is awesome. But yeah, it is it will just go up from here for them. Once they launch this, it is successful, and in future they develop their own launch pad. That's it. They don't need ISRO then. And they can have their own measures on how they want to broadcast, what they want to show, and all that stuff. So still, we are T minus 60 minutes from the launch. Things are looking good. I should 3D print and sell them. This is something, you know, I made those. This is not KSP, which I used to do before, because it really took a lot of time, a lot of time it used to take when I used to do it with KSP, and it was highly unoptimized. One of the reasons why I was not able to stream this, I have optimized now. I have full animations, full models. I'll just recreate those models, animate those, and it will be here. So once the countdown starts, when the, you know, in the subsequent live streams, you will see more enhancements in animations, more enhancement in models, and all those stuff. These are all 3D models, so yes, everything will come into again. I haven't slept all night. I was preparing for this stream. There were lot of things that I had to set up because I was doing the live stream after so long. But you know what? I don't feel like I was away for so long. Seriously, my way of talking, my way of speaking, all that stuff is the same. So that is one thing, and I really missed you guys. I can see all those old subscribers who are here. Andrew, Mars, you know, I'm pretty sure people, it's late night in the America, so people are not over there, but yes, they are coming in. I could realize many folks who are here, new and old, and welcome back, and thanks for supporting, guys. It will pay back. Things will come back to you. And right now, yep, things are looking fine. T minus 40 minutes from the launch. Let's see what happens.
From our first launch.
So you might have to imagine that it's just 6 months, and they've had to imagine, and they have to write and draft all the policies that are required. They have to make sure that they know how the mission is going to be, you know, regulated. What do we need to do to essentially handhold the space sector, the private space sector?
It was very seamless, indeed, very seamless. The way they took all of it.
Yeah, very true. It definitely is not an easy job, and they've excelled at it. Same goes with ISRO. We've had, you know, cases where they've been chasing after us.
Yeah. I remember those days.
Yeah, and it's quite, you know, empowering to know that the government is playing such a huge role in helping make this happen. We talk about Atmanirbhar Bharat, we talk about Viksit Bharat 2047, and all of these technologies, what the private sector is trying to build today, is essentially contributing to that goal. If we want to be the world leaders, we need to start now.
Exactly, Suyesh. Like, I was fortunate enough to visit the LPSC test facility when I was with the Raman 1 test campaign. It was a very great experience. I mean, and the coordination with ISRO teams and the way they facilitated the entire test campaign and the data analysis, and post-test, the data came like really fast, and like they were after us and they were very patient with us. So yeah, that was a really great experience for the young engineer like me.
Yeah, and that sort of reminds me to the stage test that we did just a couple of months ago. I think nearly 9 months ago.
Yeah, around I think October.
Yeah, October I think. And so that was the test of the orbital adjustment module. It was a all-inclusive test. We had the entire stage. We had all the engines, the thrusters. We had the avionics. We had something quite interesting and melodic as well. We played Sare Jahan Se Acha using the Raman Mini thrusters on the stage, which was something very unique, very captivating to the young minds. Many people did not think that you could play music out of the screeching sounds of 50 Newton Raman Mini thrusters.
Again, an opera, I told you, right?
Yeah, definitely.
This is what they do for fun, guys. The space nerds. This is rocket nerds. This is what they do for fun. They use engines to play sound, to play music. That's how they do it. Okay, T minus 11 minutes. So anyone joining in, guys? This is the India's first privately developed rocket from Skyroot, which is Vikram 1, and this
T
rocket
minus 11 minutes.
is on the launch pad, ready to launch. Things are looking great. It's a 4-stage rocket, 3 stages of which are the solid rocket motors. The last stage, the upper stage, is the liquid
automated
fueled
launch sequence initiated
engine, similar to what we have for PSLV, but we don't have Vikas engine over here as of now. But since much of the heritage is taken from the PSLV, don't be surprised if
All
the
right,
one
we're at
stage
T
in
minus
future
11 minutes again. T minus
is
30. 10
replaced
minus
with
10
a
30,
liquid fuel
sorry.
engine.
And the automatic launch sequence has begun. We are in the pre-checks phase at the moment, where all the teams are essentially checking the health of the vehicle once again, making sure that all systems are operational and go for launch.
Before that, we had one confirmation that all the ground stations supporting today's mission, they have completed their readiness checks. As the vehicle travels downrange, telemetry will seamlessly transition between multiple ground stations, from Shah to Port Blair, then Bogor in Indonesia, and then finally Yatharaga in Australia. This network ensures continuous communication with the launch vehicle, with all mission data relayed back to mission control in real time.
That's right. And just to recap to all our viewers, some of the callouts that have happened till now. We first had the acquisition of day of launch winds, which is we acquire using a Doppler weather radar the winds prevalent. And as Akhil mentioned earlier, it's slightly a cloudy day today for launch, but come rain or sunshine, we are always ready to launch.
Yeah, rain can't stop us, I think.
Yeah, and the next thing that we managed to do is, of course, the guidance teams have completed the static navigation profile as well as the gyro compassing of the lens package. So this is kind of the sensor which tells the attitude of the vehicle, essentially tells you how you're oriented with respect to Earth.
Lens, the full form of lens, what they keep on saying is nothing but laser inertial navigation system. That's what it is.
Post that, like he just confirmed, we've had all the ground stations. We have 4 ground stations supporting us today. Shar, which is where we are coming to you live from, and then we have Port Blair, following which we have Bogor in Indonesia, and finally the Yatharaga ground station in Australia. So all of these ground stations essentially capture telemetry, which is the data from the vehicle,
-8 minutes.
and relay it instantaneously to us.
Yeah, Suyash, you were mentioning about how we also see the wind profiles. The wind profiles are also checked. Just a while back they were checked, and as I can see on the MCC, this wind profile or this data of the winds is also going to be uploaded into the mission computer in the sequence that is coming up. And also one of the key milestones which have been completed is the transition from external ground power to the rocket's onboard batteries. The vehicle has relied on ground support systems till now, but from this point forward, every stage must successfully power itself. So engineers, I believe, are watching the battery performances and electric health right now to ensure that the transition is smooth and every system is remaining stable as of now.
And for this ALS sequence also, we have completed all the null checks for all the stage nozzles, and the FNCs are working as fine as possible.
T minus 6 minutes 45 seconds remaining. Everything looks good. I hope we don't get a
And we're
hold
also happy that
again from
Dr.
the
Jitendra
navigation
Singh
system team at T minus 5 minutes. You can see in the on the screen things are looking fine. Everything is green. And talking about, let's talk about the payloads once again. There are 6 payloads going into the orbit. We have one payload from like two cosmetic payloads are there. One is the lab grown diamond, another is miniature statue of our 3 establishers of space science in India, APJ Abdul Kalam, Vikram Sarabhai, and CV Raman. And then we also have a satellite from Skyroot themselves, which is which they have not disclosed what is it for, but I am pretty sure it's for PR and other data, obviously some for scientific purpose as well. And we have one deployable satellite from Cosmos Space. We have one robotic arm which they're going to test, one deployer, new technology from deployer, a German payload basically. So there are in total 6 payloads which are going to space. They are targeting 450 kilometers, 60-degree altitude, 60-degree inclination. It's a low Earth orbit, and this, talking about the rocket itself, it can carry around 350 kilograms to low Earth orbit. So it's definitely a small satellite launch vehicle, smaller than SSLV, because SSLV I think can carry 500 kilograms. I have to check. It's 300 or 500. I'm not able to recall properly, but yeah, that is the case. So let's hope things go right and we get to see this launch right now. T minus 5 minutes from the launch, guys.
Confirmation that mission computer mode has been successfully changed to flight mode, and we are really jubilant, and everybody is really happy that this stage has been successfully transitioned, and now we'll move towards the next check, that is HMSA disarming.
We did not get any hold right now at T minus 5 minutes. The countdown is taken care of by the transfer to the rocket itself now, and it's in the flight mode right now.
As we
The rocket
enter
is
the
in flight
final
mode. It's
few
ready to
minutes
go.
of countdown, another key safety milestone is underway. The head mount safe arm mechanism will be activated in a while, and till now it was ensured that the ignition chain has remained safely isolated.
That's right, Vaidehi. For the viewers who are very curious for this, the head mount safe arm mechanism, which we refer to as HMSA,
T minus 4 minutes.
is a safety device which is mounted at the head of our solid rocket motors. And the whole job of this device is to safely isolate the pyrotechnics from the rest of the solid grain. And the reason why we do that is for safety, to prevent any accidental ignition from, let's say, lightning strikes. We do have a cloudy day today, and of course we have lightning suppression systems. We have 4 lightning towers on the first launch pad, but there can also be some form of electrical runaway. There can also be static discharge. So to safeguard all these devices from electrical discharges, we have a mechanical separation between the pyro devices and the solid rocket motor.
Right,
Nice.
so yes. So till now, the ignition system,
T
it
minus
was
3
in
minutes.
a protective, non-firing state, but now it's going to move on to a state wherein once the mission computer gives the ignite
There you
command,
go.
it can initiate a pyrotechnic chain of events.
That's right.
T minus
And we're at
4,
T
2
minus
minutes,
3
40 seconds
and
from
we
the
have
launch.
confirmation
Everything
that the
is looking green. Everything is happy. Everyone is happy. T minus 2 minutes, 38 seconds, guys. This is happening. India's first privately developed rocket is going to space. This is finally happening. How cool is that? So all the birds who are near the launch pad, please go away. Please go away. It's going to fly, and it's not good for you if you stay there. So let's hope this thing goes to the space and don't come back. That's the main thing. Goes to space and don't come back. Please stay at the space only.
To destruct the vehicle to safeguard the resources around it.
T minus 2 minutes.
That's right. As is with the case with any launch vehicle, we always prioritize safety, and with that in mind, we have all of these systems set up on the vehicle.
T minus 1 minutes and 40 seconds remaining, guys. If you are excited, give it a thumbs up. And let's hope, give it a thumbs up. Give your blessings by giving this live stream a thumbs up. And let's hope this thing goes to space and never come back. T minus 1 minute 20 seconds remaining.
Orbital
All
adjustment
things
module
going
is now
looking
conditioning itself and preparing for liftoff.
I'm really excited. Let's hope this thing finally flies. 1 minute remaining.
So we are nearly at T minus 1 minute.
All stations.
And
stand by for the
we
timer.
will leave you
T
with
minus
the
1 minute.
views of Vikram 1 and join you shortly at liftoff.
Minus 55 seconds.
55 seconds, guys. This is happening.
Minus 50 seconds.
India's first privately developed rocket onto the space.
Minus 45 seconds.
We are coming for you.
Minus 40 seconds. Minus 35
T
seconds.
minus 30 seconds remaining, guys. It's happening.
Minus 30 seconds.
Real-time programs activated.
T
Minus 25 seconds.
20,
Minus 20
19,
seconds.
Minus
18,
20 seconds is the
17,
call out now.
16, 15,
Minus 15
14,
seconds.
13, 12, 11, 10, 9, 8,
8, 7, 6, 5, 4, 3, 2, 1, 0.
ignition, and lift
And we have liftoff of Vikram 1, India's first private orbital launch vehicle. And we have great views coming from the tracking cameras. And isn't this quite something?
विक्रम 1 ने अपनी उड़ान भर ली है। प्रथम चरण का प्रज्वलन प्रारंभ हो चुका है। विक्रम 1 ने प्रक्षेपण पथ को लांघकर आकाश को भेदने का निर्णय ले लिया है एक ब्रह्मास्त्र की तरह।
That's very true, Suyash and Akhil. I am awestruck at the sheer power that stage 1 is producing. With this, we have two of our major prime mission objectives completed, which was successful ignition and safe tower clearance.
That's right, and we're coming up on max Q now, which is the period of maximum aerodynamic pressure, where the vehicle faces its largest aerodynamic loads as it flies through this zone at Mach 1.5 at an altitude of nearly 9 kilometers.
विक्रम 1 ने सफलतापूर्वक मैक्स क्षेत्र पार कर लिया है और दल काफी उत्साहित है इस समय और विक्रम 1 प्रथम चरण के आगे बढ़ रहा है और हमें श्रीहरिकोटा व पोर्ट ब्लेयर पृथ्वी स्टेशन से मजबूत दूर संकेत मिल रहे हैं जो बहुत ही अच्छी खबर है।
That's right, we are at a downrange distance of 22 kilometers with an altitude of 34 kilometers. And on your screens right now are excellent onboard camera views from the vehicle.
And we can also see quite nominal chamber pressure values on the MCC screen.
There you go, guys. This is looking really nice.
Of 50 kilometers.
We have stage separation.
प्रथम चरण का प्रतिकरण हो चुका है और द्वितीय चरण का प्रज्वलन भी प्रारंभ हो चुका है।
This is quite a major achievement for the nation, with the vehicle successfully separating stage 1 and the ignition of stage 2 as well.
द्वितीय चरण अपना सफलतापूर्वक कार्य पूरा कर रहा है और प्रथम चरण का दहन अथवा प्रतिकरण समाप्त हो चुका है।
The vehicle is at an altitude.
There you go, guys. Looks so good. My animations are. What is happening, man?
For today is 7.6. S2 performance normal. We've just heard call out that the S2 performance or the stage 2 performance is nominal.
ये एक ऐतिहासिक क्षण है पूरे भारत और निजी अंतरिक्ष यात्रा का।
This vehicle has crossed 100 kilometers of altitude, which is the notion of edge of space, and we have reached space, guys.
Congratulations, Vikram 1 is in space.
हमारा यान अंतरिक्ष
There you go, guys. It's in space.
We had callouts of separation of the payload fairing. We have successful payload fairing separation.
It's nearly at an altitude of 120 kilometers, and the protective fairing is no longer required and has
Stage
been
to
fully
separated.
from the launch vehicle.
और यहाँ पे द्वितीय चरण का भी प्रतिकरण संपन्न हो चुका है और
We can see the onboard camera views, guys.
That's right, Akhil. We've had successful ignition of stage 3. Vehicle is currently at 157 kilometers above the Earth's surface. It is 355 kilometers downrange,
Look at those
traveling
onboard
at
camera
nearly
views.
4 kilometers per second. Now, the
S3
telemetry
performance
will
normal.
switch over from Shar to Port Blair and further to Bogor.
अब यान अपनी अंतरिक्ष यात्रा पर निकल चुका है। तृतीय चरण का प्रज्वलन चालू है और उस
+4 minutes.
की प्रतिक्रिया नियमित रूप से चल रही है।
And as you can see on your screens, we have near exact following of the intended trajectory. The two dotted the two lines on your screen essentially indicate the current performance of the vehicle, and it closely matches with prediction. This is on your screen on board from stage 3. What you see is the rocket plume and the nozzle, and Earth, our home.
What a beautiful view! क्या सुंदर दृश्य है हमारी पृथ्वी का।
S3 performance normal.
That's what we want to hear.
परफॉर्मेंस अब नॉर्मल है या कि सामान्य रूप से तृतीय चरण का संचालन प्रारंभ हो चुका है और चल रहा है।
That's right. We've had call out that the stage 3 performance is nominal.
+5 minutes.
So stage 3 has a propellant loading of 2.5 tons, and we've had burnout of the stage 3 motor as planned at
S3
T plus
burnout.
5 minutes. Yes, we've gotten confirmation that S3 has burnt out, and now we're entering a planned coast period. Something that lasts.
Okay, the timeline of the events have messed up, but
Coasting is normal.
we are in the coast phase right now. Things are looking great.
This will last for roughly 140 seconds, where stage 3 is not producing thrust, but it's connected to the vehicle and it's gonna coast as a single body. All of this is done to manage the altitude of the vehicle and also control where the stage will re-enter the Earth's atmosphere before splashing in international waters in a safe and planned manner. And jubilant views from the launch control center, where the teams are extremely elated and excited.
Even 6 minutes and 10 seconds remaining. Things are looking great.
दृश्य दिखाई दे रहे हैं। सभी यान परीक्षण दल अत्यंत ही प्रसन्न हैं और यहाँ पर जो प्रसंग है
They are doing it on their first attempt. I can't believe it.
भारत के
Man.
निजी अंतरिक्ष उड़ान का विक्रम 1 यान अब अंतरिक्ष में स्थापित हो चुका है। तृतीय चरण अब
Look
अपने
at
coast
them. They are
phase
so
में है
happy.
और ये कोस्ट फेज अभी आप कैमरा व्यूज देख सकते हैं अपने
It is so stable. It does not even look like as if there is some issues or something.
As we can see on our screens right now, it's really amazing to see that Vikram 1 as of now is going along its intended trajectory exactly as expected. Our plots are really overlapping. The predicted velocities and the current flight velocities are exactly matching. And aren't you guys speechless right now?
I mean, yeah, मेरे पास शब्द ही नहीं है मतलब
Bhai sahab, what's
मैं
happening?
निशब्द हो चुका हूँ।
We are approaching another point where
AC separation coming up.
S3 is separated.
And we have separation confirmed.
And you see wonderful views of S3 separating.
It was not a clean separation.
Now we have
It's coming back. No, not a clean separation at all. It came back. It came back and hit the rocket. It hit the rocket. Look at that. It's stumbling. It's stumbling. It's not looking good. Not looking good. Not looking good. Okay. Okay. The control thrusters are doing. Yeah.
Can maintain connection with the ground station and the satellite can be pointing in the right direction.
control thrusters are taking the job right now, making sure the correct attitude is maintained. So I'm hopeful that things will be good enough and it will actually ignite.
Thrusters to sort of push stage 4 away from stage 3.
And you can see that.
And that just sort of guarantees that there is some minimum separation between the
there
two.
is not oh, look at that third stage, man.
आने वाला जो चरण है वो द्रव्य
stumbling
पर
actually
आधारित होगा, जिसको हम कक्षा
the fourth stage, the liquid stage is what is failing right now.
मॉड्यूल के नाम से भी जानते हैं.
I hope this is not the case and they get the attitude control back. It's not looking good as of now. The stage 3 and the separation between them is not so good. Because they are happy, I'm hopeful things are fine. And those Raman engines and thrusters are able to do their job and actually separate it and control the tumbling. I feel like that, yes. Yes, might be. Actually, they don't use any cables and as such, they use a pneumatic actuators. I think now it's gone. OM ignition. And it has ignited.
S4 or stage 4 has ignited successfully.
Which is good to hear.
और अंतिम चरण का भी प्रज्वलन हो चुका है.
The liquid engine has come alive over 400 kilometers above the earth, beginning a burn that will last for more than 6 minutes. During this phase, the vehicle will steadily accelerate from about 6.68 kilometers per second to nearly 7.64 kilometers per second, delivering the precise velocity needed to achieve its planned 450 by 450 kilometers circular low Earth orbit at a 60-degree inclination.
Yeah. Things I just want to see the graph. Is it following the actual graph which it has to follow? Because they are happy, that means it should find. Oh, look at those onboard camera views.
का एक प्रसंग आ चुका है और आपके ऑनबोर्ड प्रक्षेपक पर्दों पर हम देख सकते हैं कि पेलोड्स या जो उपग्रह हैं उनका एक चित्र. यहाँ पे सारे उपग्रह अपने स्थान पर स्थित हैं.
Okay, it's not tumbling right now, which is good. That's why they were happy. They knew that their navigation system, attitude control system will actually clear out the tumbling. That was nice, but they have to actually see what happened during that separation. But yes, no hiccups till now. Whatever happened is resolved and we are still going on. T plus 11 minutes and counting.
We're traveling at 6.5 kilometers per second. And like we said earlier, OAM is essentially going to fire its Raman 2 engine for a cumulative burn time of nearly 6+ minutes. So this is the longest burning. It's the smallest in thrust, but it burns for the longest period of time.
Andrew, you are right.
And
hopefully might be that case, but when the engine fired, it might have broken and it worked.
So yes, it must be a really amazing feeling, right? I mean, you and your team worked on this engine to get it going and it is finally taking us to space.
Yeah, it's a feeling that's really hard to describe. Me and my team, we worked on this engine to get it going and it's finally taking us to space. This engine wasn't an easy design. Raman 2 generates 1500 newtons of thrust. And it employs 3 different types of cooling. If one wasn't enough, we had to put in 3. So we have regenerative cooling, then we have radiative cooling, and we have film cooling. And all 3 of these need to work seamlessly in sync to deliver this phenomenal outcome. So I'm kind of glued to the screens right now. You might just see me peeking over to try to see what the chamber pressure, what the thrust, and what the temperatures are like. But I think I might have to hold for a bit and look at that data.
It's looking good right now. So they, yes, as they said, they had to have those three ways of cooling, because the fuel that they use is not liquid oxygen, liquid hydrogen, which are cryofuels. They use earth storable liquid. So regenerative cooling using those or whatever, it might not be enough. That's why they had to have those three kinds of cooling mechanism in place.
Difficult it was to essentially design an engine this small. Like I said,
it's like Astra 2.0 Mars, right? We know what happened with Astra, right? The XY axis. But Astra was not able to go to the orbit. This one definitely is going to the orbit, which is so rare for the first time. But it's happening.
2700 degrees. That's pretty hot for any metal or any material to sustain. In fact, many metals would just vaporize into thin air at those temperatures. So to make all of this work, we employ something known as regenerative cooling.
S4 performance normal.
Yeah, and we've gotten call out that the S4 performance is nominal. And so I was mentioning about the regenerative cooling, and the best way to understand this type of cooling is to imagine
14 minutes.
multiple tubes joined side by side and then arranged into a circular fashion to form the thrust chamber. And these tubes, they need to be very, very thin to exchange heat effectively, which means that manufacturing is usually a challenge.
The graph is fine, which means any attitude or tumbling that happened is corrected by those attitude control thrusters. They did their job.
For this exact purpose, we employ something known as film cooling. And even though it sounds like a fancy name, it just involves injecting fine jets of fuel along the walls of the chamber to effectively add a barrier of colder gas between the combustion chamber and the metal walls. And essentially, one question I get asked very often is, if it's like that, then why is it called regenerative cooling, right? The whole thought process is the tiny tubes that we just talked about. Those tubes
S4 performance normal.
Plus 15 minutes.
और यहाँ पर हमको मिशन नियंत्रण केंद्र से संकेत मिल रहे हैं कि चतुर्थ चरण का भी परफॉर्मेंस सामान्य है, और अभी यान 450 किलोमीटर की ऊंचाई तक पहुंच चुका है, जो कि उसका निर्धारित कक्षा है, और कोस्ट फेज प्रारंभ है.
जी हाँ, and it's traveling at 7.3 kilometers per second at an altitude of 453 kilometers right now. So coming back to the regenerative cooling point of things, the tiny tubes around the thrust chamber of the engine essentially have fuel pumped through it.
S4 thrust cut off.
And we've got confirmation that we have cut off of the Raman 2 engine, which means
Solaris
that
satellite separate.
and we have separation of the Solaris satellite and the scope satellite.
Vikram
Both satellites
Aagaman
have
mission
been deployed
successfully.
and we have reached space on our first attempt successfully.
इतिहास में पहली बार एक यान ने अपने प्रथम परीक्षण उड़ान में ही उपग्रहों को उनकी निर्धारित कक्षा में स्थापित कर दिया है.
And now comes something very, very interesting. You can see on your screen from on board the cosmic bloom and the micro art, and we have sun rising behind it. It is the dawn of a new space era.
ये एक नए अंतरिक्ष युग का प्रारंभ है. सूर्य के किरण ने ये प्रकाशित कर दिया है.
Skyroot has actually completely redefined orbital flights, I guess, forever.
Yes, अवश्य.
Man,
ये
I'm
कथन
speechless.
बिल्कुल
They did it. They freaking did it.
So right now we are awaiting
Hello
the
everybody.
Cosmoser
Today we have
satellite
created history.
to
Vikram 1
perform.
Aagaman mission is a grand success.
And you can.
And we've heard call out from the mission director that the Aagaman mission is a grand success.
सफलतापूर्वक प्रथम मिशन आगमन ने इतिहास के पन्नों में अपना नाम अंकित कर दिया है.
Hello space, we have arrived.
They were successful because
Thank
of
you
me,
for
you know,
joining
this
us today.
100% track record of no failures with this sweatshirt. I always wear this whenever they launch critical missions, and we have 100% strike rate of all the successful launches. Even though it was a first launch, it was fully successful. Yes, they had one hiccup, but attitude control system just said no, not today, and they fixed any tumbling that happened, and finally it is in space. It is where it is supposed to be. It is not coming back, which is what we wanted to hear. And now it's a huge moment for India, because finally a private space rocket, private company rocket has gone to space on their own. That too on the first attempt. World's first to do that. Wow.
We let them celebrate. Good afternoon. I am privileged to formally announce that the first ever Indian private sector launch has been successfully completed. Not only did Vikram 1 meet its mission objective, which was simply
What I would really like this thing right here is that the people, the founders coming in and actually announcing all this, rather than them coming in, the politicians and stuff.
taken by India private company.
Yes, Mas, you are right about it.
There's not much more that I want to say on this occasion. I would like to invite Pawan and Bharat
to
talk about their journey and how they feel today, this momentous milestone that Indian private sector space initiatives have had. And I would like to thank everyone involved in this. Of course, the Skyroot team. The Skyroot team has worked day and night to make this day happen, ably supported by the team from SAR, from Extended ISRO, and from InSpace. So thank you everyone for giving India this proud moment. Thank you.
Awesome. Look at everyone is happy today. Great stream. Thank you so much, Quantum Path. Just there were few hiccups in my end also. The animations were not perfect this time, but it will be taken care of in the next stream. It was my first dry run, you know. For me also, my streams are like rocket. They don't go into testing until there is a live stream actual happening. That's how it works for me. Let them speak. Come on, speak up. Modi ji. Modi ji.
आ रही है।
मोदी जी।
हेलो।
There you go.
Hello.
Hello, sir.
हेलो नमस्ते कौन बोल रहे हैं
Hello. We are Pawan and Bharat from Skyroot.
कौन बोल रहे हैं
Sir, we are very privileged to hear you. First, your voice after the success.
पवन भारत और पूरी टीम सबसे पहले तो आपको बहुत बहुत बधाई आपने दो काम किए हैं एक तो आसमान में नए पौधे गाड़ दिए हैं और दूसरा जमीन में भी उस रूट्स को आपने मजबूती दी है
Yes, Modi.
जो देश के नौजवानों को आगे आने की प्रेरणा देगी और मुझे ये सफलता के लिए तो आनंद होना ही होना था लेकिन आप लोगों ने जिस कमिटमेंट के साथ मेहनत की, और मैं जब आपके इन्फिनिटी कैंपस के उद्घाटन के लिए आपके साथ जुड़ा था, मेरे तो मन करता था मैं पहुंचूं, लेकिन पहुंच नहीं पाया, लेकिन आपके साथ वीडियो से जुड़ा था। और आज भी मैं इस पूरे लॉन्चिंग कार्यक्रम को देख रहा था। कब से मेरा ध्यान जो गया, आपकी पूरी टीम 25-30 साल की दिखती है, ये मुझे और खुशी दे रही थी। शुरू में आपके चेहरे पर चिंता भी नजर आती थी, लेकिन फिर मैं देख रहा था कि खुशियों से माहौल भर गया। मैं आपको, आपकी पूरी टीम को इस महत्वपूर्ण निर्णय के लिए और महत्वपूर्ण सफलता के लिए मैं बहुत बहुत बधाई देता हूं। जब हम स्पेस को प्राइवेटाइज करना चाहते थे, तब मेरे सामने कई सारी आशंकाएं रखी गई थी कि ये तो हो नहीं सकता, कैसे करोगे, वैसे करोगे। लेकिन मैं इसको आगे बढ़ता ही गया। अब आपके कारण मेरे उस निर्णय को ताकत मिल गई है। अब मेरी टीम भी स्वीकार करेगी, यहां देश के नौजवानों पर भरोसा करना चाहिए, उनको काम देना चाहिए, और वो करके दिखाते हैं। आपने काम करके दिखाया है। मैं आपकी और आपकी टीम को फिर से एक बार बहुत बहुत बधाई देता हूं।
Hello, sir. Thanks a lot for your wishes. And our team, entire team of Skyroot, more than 1,000 people are here in Sriharikota, and listening to you, our hearts are swelling with pride, and this means a lot to us.
देखिए, मिशन आगमन है। अब आगमन को तो और आगे बढ़ते ही जाना है।
Right.
Sure, sir. और सर आपका कार्ड जो आप भेजे थे, that has successfully reached space, and you have written Vande Mataram. So Vande Mataram is in orbit.
देखिए, मेरे लिए बहुत खुशी की बात है। जब आपने ये सुझाव भेजा तो मेरे मन में कई विचार आए थे, लेकिन आखिर मैंने सोचा मैं सिर्फ वंदे मातरम लिखूंगा। उसके दो कारण थे। इस बार हमारा देश वंदे मातरम के 150 वर्ष मना रहा है, तो मैं चाहता था कि इसको एक नए तरीके से मनाएं, और वंदे मातरम ही था जिसने देश के नौजवानों को हमेशा देश के लिए जीने मरने की प्रेरणा दी थी। और आज वंदे मातरम हमें देश के लिए जीने की ताकत देता है, और आप लोगों ने जी करके दिखाया है। आपका जो कुछ भी मिशन है, मैं इसको एक प्रकार से वंदे मातरम मिशन ही देखता हूं कि भारत मां की गरिमा को नई ऊंचाइयों पर पहुंचाना, नई पीढ़ी को टेक्नोलॉजी को लाभ देना, और नई पीढ़ी को टेक्नोलॉजी में आने के लिए प्रेरित करना, हर प्रकार से। और उसमें से मेरे मन में विचार आया कि लंबा कुछ ना लिखूं, सिर्फ वंदे मातरम मेरे भाव व्यक्त करूं। और मुझे खुशी है कि कल आपने उस बात को मीडिया से भी शेयर किया, और आज इस सफलता के साथ वंदे मातरम का भाव भी नई ऊंचाइयों को पार कर रहा है।
Right.
Thank you, sir.
Done.
मैं आपकी पूरी टीम को बहुत बहुत बधाई देता हूं, और जल्द से जल्द आपको मिलने के लिए निमंत्रण भी देता हूं।
Thank you, sir. Thanks a lot. Thank you, sir. We are privileged to hear you. I'm privileged to have your blessings. Entire team of Skyroot, entire India is really proud of your initiative to start the space program, open it up to private sector, and now we see historically, first time probably a private company have built and successfully reached an orbit in the first attempt. Thanks a lot. It's happening from India, and this is a 100% designed in India rocket, 100% manufactured in India, and and I think thanks to entire team Skyroot, whose average age is just 28 years.
देखिए समय था जब मैं आत्मनिर्भर भारत की बात करता था तो ना समझी में कुछ लोग उसकी मजाक उड़ाते थे, लेकिन आज आपने सिद्ध कर दिया कि हम इस क्षेत्र में भी आत्मनिर्भर बनने में समर्थ हैं और आपने उस समर्थक को दिखाया है और मैं पक्का मानता हूं कि अब सबूत हमारे सामने है, साक्ष्य हमारे सामने है और ये आपकी टीम ने करके दिखाया है।
Thank you sir, thank you.
आज तो आपकी टीम खुशियां मनाने में लग रहेगी।
जरूर सर, एंड इनफैक्ट हम जब 2018 में स्काईरूट स्टार्ट किया था उस टाइम पॉलिसी नहीं थे, देयर वाज नो फंडिंग एनवायरनमेंट और प्राइवेट सेक्टर में टैलेंट भी नहीं था और हम फिर से हमारा जॉब्स छोड़ के स्काईरूट चालू किया था एंड नाउ वी आर वेरी प्राउड दैट द गवर्नमेंट इज enabled us and opened up the sector to private players, and now we stand as India's first private company which have launched a rocket to orbit and also created a global milestone, all from India with a fully Indian team, 100% built in India. Thanks a lot for enabling this journey and also setting a vision, big vision for 50 launches in 2030. Definitely I don't see it as a challenge, sir. Thanks a lot for your encouragement and looking forward to meet you, sir, in person.
आप आगे बढ़िए, मैं पूरी तरह आपके साथ हूँ और आपको तो आगे बढ़िए नहीं कहना चाहिए, मुझे कहना चाहिए और ऊपर उड़िए।
Thank you, sir.
जरूर सर, thanks a lot, sir.
चलिए बहुत अभी आपको कुछ न कुछ काम होगा, लेकिन सबसे पहले मेरा आपकी टीम को सचमुच में मुझे देखकर तो खुशी हो रही थी कि इतने मेरे देश के नौजवान क्या कमाल कर रहे हैं, यही मेरे लिए खुशी की बात थी। बहुत बधाई फिर से एक बार और बहुत शुभकामनाएं। और आपने जो टारगेट तय किया है वो समय से पहले टारगेट पूरा होगा, मुझे पक्का विश्वास है।
थैंक यू सर, थैंक्स अ लॉट। हम जरूर कोशिश करेंगे।
ऑल द बेस्ट।
थैंक यू।
Oh my god, what was that? That was totally unexpected. That was really awesome also.
Come.
And what I really liked was founders were the one who talked to him and now they are talking.
Absolutely no words. Go! It's so heartening to hear the Honorable Prime Minister talk so highly about Skyroot, so highly about India's youth. I think this is a historic moment, not just for Skyroot, for India and also entire global space sector. In the first attempt reaching orbit, I never thought it was possible, and Skyroot team made it possible. Big shout out to this phenomenal team which made it happen. And in fact, this launch was nothing short of a suspense movie. We all experienced the highs and never have we seen such suspense, and I think it's all worth it at the end. And I think really happy today and that we have achieved something very rare, very unique. It shows the potential of India's talent. And today, in fact, we stand here at one of the best spaceports in the world, and we are very proud to launch Vikram 1 from the most versatile launch pads in the world, and really thank ISRO for enabling this. And more importantly, I would like to appreciate and also thank entire InSpace team, which has efficiently authorized this launch. And in fact, I've seen countries, companies waiting for launch authorization for so much time, and India has proved it that government is the most efficient, and in fact they enabled this launch in record time. There was zero delay in authorizing India's first private orbital launch.
Wow.
And like I was telling the Honorable Prime Minister with pride, you know, this is a 100% designed in India rocket, 100% made in India rocket, built by 100% Indian people, for India, for the world. So in fact, I've written a speech, but I'm just like out of words. And I'm so happy today, and really, this journey is only possible because first, Team Skyroot, of course, the government, the Honorable Prime Minister, for his vision to open up the sector to private players. And then now today, India is proud to be the fastest growing space tech ecosystem in the world. And now we achieve one of the biggest milestones ever in India's space sector. First private orbital rocket reaching orbit in the very first attempt. It still feels like a dream, and you all made this dream happen. I have no more words, and really appreciate everybody making this happen. In fact, we can see, I think all the hearts were racing up. It was not Skyroot, it was not InSpace, it was not ISRO, it was not the people watching, the public watching in the gallery, people watching online. Everybody's heart was beating for India, everybody's heart was beating for mission Aagaman. And we made it happen. It's one nation, one mission for the world. Thank you.
Yes, indeed it is.
So I request all the Skyroot folks here just come up on the stage. Don't leave any inch remaining on the stage. Please occupy the stage now. So as mentioned, like simply like we wanted to prepare something, but there's just simply no words. I just wanted to send the deep sense of gratitude to InSpace for being the enabling pillar.
Wait, what? Wait, what? What has happened? Has happened? Why it has happened? They just ended the stream abruptly. Are they streaming through? Ended it abruptly.
And in fact, they enabled this launch.
Okay, nice, cool. Okay, then I think that how cool was that? Let's go to X and see what's happening over here. But yes, guys, now India has the name of the first ever launch that has happened for the first flight, and that too was successful. Finally, this is something to be very proud of, because this has never happened before, that a rocket in its maiden flight achieved orbit without any hiccup. Yes, there was an hiccup, but the attitude control systems just flaunted their strengths, and then finally reached the orbit without any issues. I literally, in the graph side, we did not see any deviations from its intended path, which was so cool, so great. And then this finally happened. Man, this looks so good. Modi's number. It's not his number, but yes, finally. Okay. This has happened now. This has happened now. We are in the space. These guys finally launched their rocket, and I'm just out of their words. Like, seriously, man, this is something which I was waiting for so long, that some good news coming out of India about space and rockets, and let's just
First private orbital launch.
Lift off.
see
4,
it in
3, 2, 1, 0.
Okay.
And
Let's see it in repeat. Yeah, so I was saying that I was hoping for India to do something. ISRO last launch from ISRO was in January 2026, and they have been very, and that too was unsuccessful. And previously also it had very it did not have a good success rate. Some very bleak days, gloomy days were happening in India in the space sector. Everything was very you know sleepy, lazy. It just did not feel right, and now this happened. Was waiting for it, and I was kind of, I don't know why, but today I felt like this launch will be successful, and yes, it was successful finally. That was something which is to be proud of, being in India. Yes, Devaprati, we did it finally, we did it. This is something to be proud of. This is something to be really proud of, because maiden flight, going to the orbit in the first attempt. I have streamed so many maiden flights of so many rockets around the world, but believe me, this is the first time that it has happened. We did not face any issues, and the orbits is in their orbit. The rocket is in the orbit. Wow, just wow, incredible, and wow. I'm now hoping whether someone has captured from the, there you go, grounds and everything, right? We have one picture, looks cool. We were just, man, this is so good. This is so good. Even Agnikul Cosmos tweeted. Agnikul Cosmos has retweeted. This is great. And now hoping Agnikul also to be bold, and we have. So what Agnikul has announced is that they will be attempting a SpaceX style rocket recovery. They haven't reached the orbit yet, but that's what they said, that they will be attempting it very soon. So yeah, it's nice. That's good. So this is good. This is the first step of many. I'm hoping that once this is taken care of, Skyroot will move on to the liquid fuel very, very soon. And talking about Skyroot and their plans, they have this. Go to their website. You will see they have this new. Okay, this is the, obviously they haven't updated the website for that. The thing which they are doing. Vikram 1 is completed. This is done and dusted. You can see all that stuff, made in India and stuff. But this is the one which I was talking about, the next big thing, which is the Vikram 2, powered by a cryogenic engine. Vikram 2 offers greater payload capacity and orbit agility, and launching in 2027, they say. So Vikram 1 is done and dusted. Now they are going to go for a Vikram 2, guys, which will be featuring a cryogenic engine. Let's see how well they do it, because obviously the timings in the rocket industry are a bit off. But yeah, Vikram 2 launching 2027, up to 900 kilograms to low Earth orbit, 600 to sun synchronous orbit. That is good amount of payload capacity, and everything is made in India. Everything is payload. This thing is composite, carbon composite structure they have used. Rideshare programs they will be having. So they are on the right track. They are doing the stuff which they should do for the maiden rocket companies in India. Now they are just waiting for what, the second launch to happen, the Vikram 2 to come and do its job. So yeah, I think that should be it. I hope you like this stream, guys. So it was something which I was looking to, I haven't slept all night. I was preparing for this stream, making all these models and everything, and finally it paid off, which is great, which is awesome. And talking about me and the Rocket Gun 2.0, it's coming, guys. I had many more things in plan for this stream, but it was made in so much hassle that some corners were left untouched, which I will resolve for the next streams. You just keep on supporting, like this stream, subscribe if you haven't, because things will heat up from now on, because I have made the comeback, videos, live streams, and all that stuff which you love from me will be very soon, very much soon happening. Starship Flight 13 is also very soon happening in 2 days from now. So I will be trying for that now. Okay, I will be trying for that now, making all the stuff which is needed for that launch. Okay, we'll do. No worries, we'll do it. Okay, cool then. Thank you so much for tuning in, guys. If you did like the stream, give it a thumbs up. And if you haven't subscribed till now, do subscribe. And I will be meeting you soon. Meeting you soon for the Starship launch. Till then, take care, be happy, and yeah,